Alrighty, good evening everyone and welcome. Thank you for joining us here at the EMC Pivotal Cloud Foundry Dojo. I'm sure as many of you are aware, we started our digital transformation earlier this year by opening a dojo and contributing to open source software. And we face some of the same challenges that our customers and partners face, which is how do I get started? And we leveraged many resources, Eric Rees being one, the Lean startup and running Lean. And somebody who was invaluable to us was also Dan Ward and the principles that are talked about in the Simplicity Cycle. So it is for this reason that it gives me great pleasure to welcome Dan to the dojo to talk to us about the book and the principles and also be able to answer questions for us, right?
Absolutely.
The best part, the interactive part.
Absolutely.
And you have books with you?
I do.
Awesome. $18?
$18, that's right. A little bit less than what Amazon charges.
And you'll sign them.
I will.
Perfect.
Yeah.
All right. Cool. So over to you. Thanks,
Cool.
Dan.
Hey, thank you. Thank you. Thanks. Well, good evening, everybody. Thank you so much for coming out. And Brian and Sydney, wherever you are, thanks so much for all the hard work you did to make tonight possible, to make it happen. I appreciate the invitation and the opportunity to come out here and talk about this crazy little thing called the Simplicity Cycle. Two real quick notes before we dive into the content here. First, please don't hold your questions to the end. I certainly have comments to make here, but my objective is not to just get through my script. My objective is to connect and engage, and that works best if you also connect and engage. So don't hold your questions to the end. If you have a comment, you want a story to share, raise your hand and we'll jump right on that. Second, those of you who are on Twitter, feel free to live tweet. I love it when people live tweet my talks. Take a picture of a chart that you like and tweet that out, or if somebody says something interesting, feel free to jot that down. And we got a hashtag Simplicity Cycle that I use fairly often, so again, please feel free to use that as well. I'm at the Dan Ward, and of course at EMC Dojo, tag those as well. Any questions so far? Awesome. Well, let's get started. So the title of the book is called The Simplicity Cycle. Now, it might surprise you a little bit if I tell you that our topic tonight is actually not simplicity. What? It's crazy, but it's true. We will be talking about simplicity, but that's not the deeper topic. That's not the bigger purpose of our time together here tonight. So as we go along, see if you can pick up what the real theme, the real topic, the real goal of this discussion really is. But let's talk about simplicity, at least to start off with. Simplicity is kind of a weird topic, frankly. People have sort of a spectrum of opinions about simplicity. On the one hand, you get people who are just really, really in love with simplicity, and they'll say, keep it simple, stupid, and just simplify all the things. And you know, sometimes simplicity fans, simplicity advocates, and simplicity gurus can overvalue or overstate the value of simplicity. They overemphasize simplicity to the point where bad things can happen. On the other end of the spectrum, though, are the people who have a negative opinion about simplicity. Those people exist. In fact, I was on the phone with a potential client one time, and he actually said, "We are not interested in simplicity at my country and in my company." In my company, he said, "In fact, I fear simplicity." He did not hire me, as you might imagine, but I probably could have helped him. But I get it. I really do. I sympathize and I empathize with that perspective because oftentimes simplicity is inadequate. Simplicity can be sterile. Simplicity can be underwhelming. Sometimes simplicity is exactly what we don't want, what we don't need. But sometimes it is. And that's really where this Simplicity Cycle concept comes into play. I developed it to help us, to give people a framework for making good decisions about simplicity and complexity in the things we design, in the things we make, and in the things we use. But also I developed it to help us have conversations about simplicity and complexity. Help us talk about it with our colleagues, with our clients, with our customers, and with the world around us. So having said that, anybody else's office look exactly like this? It's a complicated world these days, isn't it? There's a lot of complexity around us. Anybody want to guess where I was when I took this picture? Amazon. Amazon's a good guess. I was in the basement of a major television network. I won't tell you which one, but I'll give you a hint. It has both a B and a C in its three-letter name. So this is the basement of a major television network. And I think this is just a perfect metaphor for the world today. There's so much complexity out there. It's maddening, it's frustrating, it's useful, it's important, it's unavoidable, it's valuable. How do we navigate under conditions of complexity? How do we move around when our world and our life looks something like this? Well, that's what the simplicity cycle aims to help us do. So let's jump right in here. The action takes place on this little XY axis, and I want to take a moment just to talk about the two words that are on the chart. On the horizontal axis here, the Y-axis, we got the word complexity. Complexity is an ironically simple topic. There's a lot of different definitions we could give for that word. The definition I use, complexity just means consisting of interconnected parts. So something can have a high degree of complexity or a low degree of complexity. You might notice there's no numbers on this chart, so it's not as if 100 equals a lot or a little. It's domain dependent. Context matters here. So if something has 100 parts, that might be a very complicated pencil sharpener, but a very simple spacecraft. So what constitutes a lot in your particular context might be different than in somebody else's context. Now the word goodness on the bottom, again, is also domain dependent. It's going to mean different things in different situations. Goodness is a little bit more complicated. There's a little more nuance to this word goodness. And goodness is a general term that I use to refer to any number of different measures of merit, whatever the desirable attributes are. Goodness might mean value, it might mean fitness for use, it might mean effectiveness or efficiency. When I was in grad school, I had a professor who hated my simplicity cycle and was not shy about telling me how much he disliked my simplicity cycle. When you get feedback like that, it's important to listen to it, to let it sink in and pay attention to what is this person really saying. The thing he hated about it was this word goodness. The reason he hated the word goodness is there had been a television commercial for, I think, peanut butter. Stay with me. There was this commercial for peanut butter, and the commercial said, "Moms love this peanut butter because it's full of goodness." And he's like, that's just a meaningless marketing word. Goodness doesn't mean anything at all. Why would you buy goodness peanut butter? I don't remember. It might not have even been peanut butter. It might have been jelly. I don't know. But he didn't like the use of the word goodness because within that context, it was a meaningless marketing word. And I have deliberately underdefined the word goodness here. So he was right that when I use the word goodness, it's going to mean different things in different times, in different contexts. But I think that is precisely why it is exactly the right word to use. We don't always know what the word goodness means. In order to use this chart, we need to have a definition. We need to have a consensus. And this forces us to have that conversation, to talk about what represents value in this domain, in this project, on this PowerPoint deck, on this bit of code that we're working on. That's really the point of all of this. That's the big topic. More than simplicity, more than complexity, goodness. Now, as an engineer, as a designer, as a coder, as the program manager, I get to have an opinion about what represents goodness on any individual project. I get to be part of that conversation, but ultimately I'm not the one who gets to define goodness. Anybody want to guess who does get to define goodness? And any?
Webster's.
What's that? Webster's has an opinion, sure. But within any given project, within any given domain, any given problem-solving set, any given product, who gets to define, is this product good? The customer, the user, the person on the end who's going to be receiving the effort, the result of this effort. So again, as the engineer, as the program manager, as the coder, I'm part of that conversation. I can shape the user's opinion about whether this is good or bad. I can help them see, hey, this is a good aspect, a good piece of the design, but ultimately I don't get the final word. Ultimately, the user is the one who defines the word goodness. And that's why I think it's so important to underdefine the word now, but to continually revisit the word and to ask the question, what does goodness mean today, here, on this? Because it might mean something different than it meant yesterday over there. Okay, so yes.
Go back to complexity.
Uh-huh.
Is it fair to say that complexity and simplicity are antonyms on your chart, or
Yes.
it is?
Yeah, so something can have a high degree of complexity or a low degree of complexity. If it has a low degree of complexity, we could say it's simple. Good question. I like it. So when we sit down to design something, we don't always get to begin with a blank sheet of paper. Sometimes that happens, and it's nice when it happens, although it can be hard when that happens. not sure I have a full preference whether I want to start with a legacy system or start with a blank sheet of paper. All else being equal, I do like the blank sheet of paper approach. When that happens, there's only one design move available to us when we're sitting down and facing a blank sheet of paper, whether we're going to be writing code or making a PowerPoint presentation or a process design or an org chart. The one move available to us is what? Is to add, to introduce something, to put some pieces and parts and functions into our design, write them down on a piece of paper. And why do we do that? We do that because it makes it gooder, right? It makes it better. We've increased goodness. So as we introduce new pieces, parts, and functions, complexity goes up, and the reason we introduce these pieces, parts, and functions is to make it better, so goodness also rises. And as long as we are continuing to add things that represent improvements, we're moving on a path that looks something like this. It might not be exactly straight. The angle might change from time to time. It might wiggle around a little bit. But if our additions are also improvements, the general trajectory is going to be up and to the right. Here's the thing. A lot of people seem to believe, or we act as if progress and improvement always follows a path that looks like this, sort of indefinitely. It doesn't. We can't continue up and to the right in an unlimited fashion. And I'm not sure anybody really loves complexity, but we love to add things, don't we? And by adding things, if we add too many things, then we kind of get surprised that things got too complicated. So we can't keep going up and to the right as much as we might like to. At some point, though, we hit this critical mass of complexity in the middle of the chart where beyond that point, any new features, parts, and functions, any new additional components actually start making the thing worse. Complexity continues to rise. As we move up and to the left, complexity is getting higher. And sometimes we can take comfort in the fact that complexity has risen. Because complexity looks like work. When I add a new piece, a new part, a new function to the design, it looks like I did my job. I've contributed to the development by, hey, I put in a new function. I wrote some more code. I added a new module. I built a new deck of charts. Did they make it better? Beyond this little yellow dot in the middle, beyond that point, we have added things in a way that actually weighed the design down. Now we have gears that begin to grind against each other. We've got parts that don't contribute to the value, contribute value to the whole. And this can surprise us. And this is why it's sort of a problem. We're so used to seeing this happen that we get caught off guard when this happens. Because the design behaviors that served us so well, these additive design behaviors, introducing new pieces, parts, and functions, they were all good ideas up until yesterday. Now all of a sudden, I'm doing the same thing. I haven't changed my design behavior, but I'm getting different outcomes. And that can be surprising, but it shouldn't be surprising because this happens so often. It's pretty predictable that at some point you will hit that critical mass of complexity beyond which any further additions actually make the thing worse. So since that point exists, we should keep an eye out for it, we should be aware of it, and we should try to change our behavior when we realize we're approaching it. Otherwise, we end up in the upper left corner where complexity is really high, goodness is really low. This is where we find the learned professor who you hear him give a lecture and you say, he must be a genius, I didn't understand a word he said. Maybe that person's not a genius, maybe it's just a very complicated idea, but not a lot of value, not a lot of utility, not a lot of maturity in that thought. All right, so I didn't mention before, yes?
I'm going to ask you a question before you press on.
Absolutely.
So obviously the challenge is finding where that inflection point is, right? And that's going to vary depending on the application. I think of examples where you're building a product for multiple customers. So one customer's complexity that's non-value added that moves you this direction might be another customer's complexity which continues you up that curve.
Right.
So how do you sort through that? I think of my phone for a great example.
Sure.
Lots of applications that are really zero value to me, but evidently they are to someone.
Right. So that's a great question. And I would paraphrase the question a little bit. You said sort of one customer's complexity is another customer's value. I would say different customers are going to have different definitions of goodness. Different customers will also have different levels of tolerance for complexity. For some customers, a certain quantity of complexity, a certain level of complexity makes the thing less good. It's harder to use. For sort of the super user, who's maybe willing to put in more effort to learn how to use the thing, they might find that that same level of complexity is still okay, is still good. So part of the challenge then is to understand, again, the user gets to define goodness. Understand with a large user community, that's a tough answer, that's a tough spot to nail down. And as we'll see in a minute, it's not necessarily a point, it's more of a region. But how do we mitigate that when you've got one user who wants a lot of complexity or can tolerate a lot of complexity, and other users who tolerate complexity less well? It turns out when you optimize a solution, when you optimize a tool for the least capable user, you actually improve its performance for all the users to include the most capable user. Simple tools tend to outperform their specs. Simple tools tend to satisfy a broader range of interests and user sets and applications than the designers and the engineers might have anticipated. So generally speaking, the simpler approaches tend to satisfy a broader range of users and customers. Which isn't to say that sometimes it's not our right to provide a more complicated alternative for those users who want it, for whom goodness and complexity are directly proportional. And so that's why it's sort of it's an ongoing discussion. You need to, and you'll only find that out if you're engaged with the customers, asking them, watching them, probably more watching than asking even, and getting a sense of, is this complexity getting in the way? Is this complexity valuable and helpful? Does that kind of address that?
I think so, yeah.
Okay, excellent.
How about modularity?
How about
Modularity.
modularity is a great strategy for mitigating and managing complexity. Because a modular design is one where you can kind of plug and play and even let the users do some plugging and playing. So they can unplug the simple module and plug in the more complex module. And so a modular design approach gives your users that optionality, gives them the chance to engage and customize without complexifying things for those basic users. So from a system architecture perspective, modularity is both a simplifier and a goodifier. It improves the quality, improves the value of your design by making it a little more flexible, but also robustly flexible. And that's kind of key, because complexity tends to increase fragility as a general rule of thumb. More complex systems tend to be more fragile, which actually leads into my very next chart here. Yes?
With advancements in automation and machine learning, does it kind of change the vector a little bit?
Yes and no.
Systems
So
can be inherently complex
Mhm.
if they're overlaid by automation.
Right.
Can live at a higher level.
So automation and machine learning help take some of the burden of processing that complexity off of the user and kind of puts it below the skin, below the screen. There's a guy whose name I'm drawing a blank on who coined the term the law of conservation of complexity. His theory was that complexity is neither created nor destroyed. We either move it below the surface or above the surface. We let the automation take care of it, or we force the users to take care of it. I'm not sure I entirely buy that. I think it's possible to create complexity. I also think it's possible to reduce complexity. But he's kind of got a point that there are ways to hide complexity, to not expose the users to it. And things like artificial intelligence and machine learning and automation, these are a great way to simplify the user's experience while still allowing the overall architecture to have some of that richness that goes with complexity. Even within that context, though, we still want to look for opportunities or look for instances when below the skin, we've complexified things to the point where it becomes heavy and hard to debug and hard to maintain, because there's a cost of complexity below the skin as well. It's not all just about the UI or the UX. Does that kind of cover that? Awesome. Other questions? This is great. All right, so I didn't give a lot of did you have a question? Or?
It's more of an observation, I guess. Just in responding to this fresh, the two things I'm thinking are, one is, in many systems, there's different layers of description. And so a lot of things we're doing now here about is taking complex systems, but making each layer of description through having separate APIs and everything else, making it relatively simple. So your goal is
Right.
to have the max complexity in any layer of description within a constraint, as opposed to
Right.
And the other thing I'm thinking is, thinking about what complexity means when you're talking about a blank sheet of paper. Usually when you're putting in something for the first time, you're aware of what you're adding, but you're also adding a wall to block other things from being possible.
Right.
And those walls, people don't notice for a long time until they start bumping into them. And I'm wondering if the inflection point in many situations involves where the walls that you've added and not realized it start getting complex.
There's those second order and third order effects of complexity, and the more complex your system gets, the more complex your design gets, the more second and third order effects you will find. So I think I generally agree with everything you just said, and it relates back to the question of modularity as well. And that modularity, the system engineering principle of high cohesion and low coupling, it kind of comes into play here too, where any individual piece has a single function that it provides, and the low coupling means if we make changes to this piece, it's not going to ripple through the rest of the design. These are pretty straightforward engineering and system engineering and design principles that they don't cost you any more to implement them than to do it the dumb way, than to do it the bad way. But if, again, making good decisions in your designs up front is kind of a great way to maintain the valuable complexity as well as the valuable simplicity, and keep you pointed back on the whole question of goodness. Cool? Awesome. So I didn't mention a whole lot about my background before we started, but I did just recently retire after 20 years in the US Air Force. Only the last year of which did I have anything to do with airplanes. I managed to do almost 19 years in a blue uniform, not touching an airplane at all. Having said that, I do like airplanes, and my latest kick these days has been researching the history of aviation experimentation prior to the Wright brothers. Did you know for 400 years people were trying to build flying machines and failing 100% until 1903 when the Wright brothers had their first flight. So I want to talk real briefly about this aircraft, and then later on we'll see another one that's significantly different than this one. But in 1875, a guy named Moy built this rather complicated beast of an airplane. He built it at a great personal expense, and it was a very complicated, very fragile system, very expensive aircraft. And when it came time to test it, the question was, will this fly? Spoiler alert, the answer is no. But the question in his mind was, will this fly? He absolutely knew, in order to answer that question, he would have to get this thing moving at a relatively high speed. Send it down a hill, down a ramp, off a cliff. He also knew that if he sent it at a high speed and it crashed, it would break, and it would be a very expensive loss. So what did he do? He chickened out. He absolutely chickened out. On a flat and level surface at a very low speed, he kind of crept along and said, nope, doesn't fly. Now, I contend he didn't really test his aircraft. Because to test it, you would have required to expose it to that risk. He would have had to get it going a little faster. So he didn't test it. He didn't damage it. It continued to be intact. But he didn't get any of the data that he needed about, does it fly, what's wrong with it, what can I fix it? Turns out, you probably know this, but you can get zero data for free. You don't have to build a big expensive machine like this to get zero data. That zero data is absolutely for free. I give it to you right now. Here's zero data. But he spent a lot of time and money to get zero data. The reason I tell that story, complexity increases fragility. Complex designs tend to break more often. They tend to break more critically. They are harder to debug when they do break because there's more possible failure modes. And complex systems also tend to be more expensive to build, to understand, to train, to maintain, to use. And that complexity, the cost of that complexity creates a barrier to use. And when we create barriers to use, which in his case ended up being a barrier to test, that means we learn less. It takes longer to learn. This is not how you build a flying machine. We'll see a better example of a successful one in a little bit. Okay, so when we hit that critical mass of complexity at the center of the chart, from that point we need to change our design behaviors. Instead of additive moves, additive design steps, now we begin adopting a reductive design approach. We begin subtracting rather than adding, taking things out, streamlining, trimming. This shift from additive design modes to a reductive thinking mode it's no harder to subtract than it is to add. It's just unfamiliar. It's a shift in our momentum. It's a change in our design approach and our design behavior. The tools you use over here are not intrinsically harder to use. These are just more familiar. Familiarity increases ease of use. The more aware we are of a tool, the more experience we have with it, the more likely we are to use it well. And so as we begin to make this shift and we start using some new tools, it feels like we're going back in terms of our own competence. It's a little harder to do because I haven't been doing it for a while. This is called the simplicity cycle. We'll talk in a minute about how we kind of loop through this a couple different times. So the more we get used to it, the more we go through this cycle, the better we'll get at using some of these reductive tools. And ultimately what you want to do is end up down here in the bottom right corner where complexity is low and goodness is high. So I had somebody, I was at a university one time and somebody asked, how is it possible to improve a design by removing something? It just didn't compute. And I get it. Because when we take something out of a design, it looks like we have damaged it. It looks like we've undone someone else's work. And the best example I've come across is, you might remember Windows XP. Windows XP, when you put that on a laptop, no kidding, there were 15 ways to shut it down. There was sleep, there was hibernate, you could close the lid, push the power button, a couple of different key combinations, 15 ways to say, I'm done using this now. There was a good reason for each of those mechanisms. There was no good reason for having all 15. So with Windows 7, which was the next, the follow-on version, they streamlined and trimmed and took a lot of these unnecessary, extraneous, took a lot of these mechanisms out. The final code with Windows 7 was easier to maintain, easier to debug, much more reliable. It had fewer failure modes because it was simpler. And this is the same kind of thing that a sculptor will do. You take a large block of material and you chip away all the parts you don't want to keep. The final product weighs less, but it means more because we've removed the pieces that don't contribute to the value of that design or that image or that object that we're trying to sculpt. Okay, if you've ever played with a rubber band powered toy airplane, you have this guy to thank for it. Alphonse Pénaud, I'm probably mispronouncing his name, in 1871 was the first person to create a rubber band powered airplane model. This is some 30 years prior to the Wright brothers' first flight. These twisted strings of India rubber was how he described them. I got these pictures and these stories from a book called Progress in Flying Machines, written by a railway engineer named Octave Chanute, published in 1894, 9 years before the Wright brothers had their first flight. This guy's amazing. He's a railway engineer studying aviation at a time when aviation didn't exist. It's kind of like internet millionaires today, you know, launching rockets and trying to do space missions, because the railroad was the internet of his age. And he had definitely made his mark. He designed the stockyards in Kansas City and Chicago, built a bridge across the Mississippi. I mean, leading thinker in the cutting edge tech field of his day. And he writes this book about 400 years of failed aviation experiments. What a remarkable book to write. I'm going to write about a topic, a problem that has yet to be solved. And among the stories that he told was this one. He says, look, this model, what we think of as a toy now, this taught us brutally, critically important lessons about lift, thrust, about where to put the center of mass. Do you move the wings a little closer to the nose, a little closer to the tail? Where should the wings be on the fuselage? Nobody knew this because nobody had built a flying machine that worked yet. These were simple, they were inexpensive, they were highly effective. And gosh, that looks a lot like a plane we would see today, doesn't it? Only difference, of course, is he had the propeller on the back. He later moved it to the front in some of his other models. But these were inexpensive enough to build, to modify, to let them break, to figure out what was right, what was wrong. This is the kind of experimentation that you can achieve. This was big science. Let me just be really clear. It's a toy today. It was big science back then and solved. He answered some unanswered questions, some really important unanswered questions, and laid a great foundation for the aviation experiments that would come on later. Important, successful upon the small scale on which it was tried, vastly different than Moy's complicated, expensive machine that never quite got off the ground. It's clearly residing here in the bottom right corner. Now, here's the other twist. If the first twist was that We can't follow this trend indefinitely. We can't keep going up and to the right. The second twist is when we get down to the bottom right corner, we don't get to stay there. Time exerts constant pressure in the direction of decreased goodness. Let me say that again. Time exerts pressure in the direction of decreased goodness. Today's breakthrough becomes tomorrow's commodity. The thing that I design that's good today doesn't stay perpetually good because alternatives continue to change. The market changes, the economy changes, competitors introduce new alternatives. And now all of a sudden I'm not competing with what used to be around, I'm competing with something new, and maybe my design doesn't look as good compared to that as it did compared to yesterday's model, yesterday's competitor's model. So when that happens and we slide all the way over to the left, we find ourselves here again, and guess what? The next move is to begin adding again. And that's why I call it the simplicity cycle. You iterate through. Design is an iterative process. Increase complexity, decrease complexity, rinse, lather, repeat. Lather, then rinse, then repeat. There we go. All right, now the question I think which has already sort of come up, I think somebody asked it earlier, how do you know where you are? This is inevitably the first question that people ask. How can I calculate quite where I am in this XY chart? Turns out that's not the use case. That is almost never the use case. The right use case is how do you know where you're going? The reason your location, well, in engineering terms, your vector matters more than your position. Where we're heading matters more than where we physically are at the moment. You may need to have a sense of where you are, but it's more important to have a deep understanding of, is it getting better or is it getting worse? The reason your vector matters more than your position is that if you're here, how do you know which tools to use? Well, you can't tell which tools, whether you should be using additive tools or reductive tools. You can't tell which tools to use just by your position. Your vector will tell you which tools you need to use. If we need to move up and to the right, we need to increase complexity as a way to improve the design, that's the time to use additive tools. If we need to move down and to the right, if our vector needs to come in this direction, now it's time to use reductive tools. So with my projects that I've led, with my customers, with my clients, and how I use this is we'll sort of just sketch out complexity versus goodness on a whiteboard or on a napkin around a table and say, all right, where do we think we are, but more importantly, where do we need to head? What's been our general trajectory? Are we moving in a good direction? Are we, oftentimes, the answer to this question is we can't answer it at the time. We can kind of answer it in hindsight. Hey, 2 moves ago, I think we went around the corner. 2 moves ago, we started making things worse. Intuition, which oftentimes is informed by experience. The insight of others, getting other people's opinions. Where do they think we are? But more importantly, where are we heading? Which direction should we be heading? And is our trajectory generally to the right? And the other reason your position matters less than your trajectory is this. It doesn't matter whether we're at this yellow dot or that yellow dot. In both cases, the prescribed behavior to move down and to the right, to simplify, to trim, to take things out, to subtract, to use these reductive tools, the prescribed behavior is the same. So your position won't determine your tools. Your trajectory will determine your tools. And here's an instance when 2 different positions, same strategy, same proposed remedy. So I mentioned design tools and design techniques. You can go to my website and download this quick reference guide. This is a small subset of some of the worksheets that I use when I do workshops. And so again, the details are in the book, but if you want to get just the quick reference sheets, you can go over there and download those as well. The other big use case for this, actually let me take a pause. Any questions so far? All right, the other big use case is my favorite question in the world. Maybe not in the world, but my favorite question in the design world. What if we do a little bit less? What if we do a little bit less? Sometimes the answer is if we do a little bit less. Doing less generally means reducing complexity. We'll satisfy fewer requirements. We'll write fewer documents. We'll simplify our system, simplify our design. Complexity goes down. Sometimes goodness also goes down. Sometimes the answer is, if we do a little bit less, that would be worse. In that case, don't do less. Do the same or do more. But in other cases, if we do a little bit less, that would represent an improvement in performance and efficiency and effectiveness, in value in the customer's eyes. And in that case, we should do less. What I love about this question is that it seems like it's about simplicity. It's actually about goodness. Because we can't answer this question without first talking about this part of the puzzle. How can we determine our trajectory? Is it down and to the left or down and to the right? We know it's down. Doing less would take us down, but does it swing with less goodness or more goodness? It's kind of the sneaky application here. This forces us to have a conversation. What does goodness mean in our context, in our domain, on this project, to these customers? We may discover we don't know. We may discover there is no consensus. We may discover we thought we knew what it was, and it turns out we were wrong. This is the point. And so by asking this question and continually asking the question and being open to two different answers, less would be better, less would be worse, we're continually engaging with this tough question of what does goodness really mean? What does value really mean? How are we affecting goodness? How are we affecting value with our design decisions? And again, you can't answer this question without addressing that.
Right? So,
Yes?
so isn't the answer, yes, we should do less, you know, isn't this kind of orthogonal to MVP, build, measure, learn, iterate, you know, with passion? And because we, like you said, we can't answer the question. The judge of goodness is our users.
Right. So we can't answer the question alone, I should say.
Because you won't know until you have something that is, you know, measurable, if you will, by a customer,
Thanks.
or accepted by a customer, or a base of customers. And failure is built into the model, right? We will
Right.
fail.
Yes.
Right? We will implement something or take away something, right? And we won't know it until users get their hands on it and use it.
Exactly. Which is really kind of the point, is that since we can't answer this question until we address this, and the users are the ones who can answer this goodness issue definitively, that forces us to try these minimum viable products, to put stuff out in the world, to get that direct user feedback, and then to roll that into the next cycle, the next iteration of our design. But it is entirely possible to do less, to simplify in a way that hurts your design, to take out something essential, to take out something that the users are like, well, I loved that. I use that all the time. That's what I bought your product for. I need that to be back. It's possible to make that mistake, absolutely. That's the least likely mistake to make, though. Generally speaking, we have a tendency to overcomplicate things, and so simplification, for the most part, as a general rule, simplification tends to make things better. But I don't want to say it always does. It is possible to break your design by oversimplifying. Yes?
Doesn't it become more a matter of degree of who you upset when you remove something?
Say that.
Doesn't it become a matter of degree of who you're going to upset when you remove something? Because you're always going to be upset at someone when you remove something.
Yes, especially if you have a large, so the question was, isn't this really a matter of degree? If you have a large and diverse set of users and customers, you're not going to satisfy all of them. True. So when I was in the Air Force, I had a chance to go off and talk with the folks who worked on the GPS system, the Global Positioning Satellite. In this particular office, their job was to build these little chips. And these chips were basically signal receivers for the GPS. And for those who aren't familiar, the GPS is a constellation of 24 satellites. And they send out different radio signals that each performs different functions. So one is for accuracy, and one is for anti-spoofing, and anyway, there's a number of different reasons for these different signals, and they are YMCA. I don't know if that was on purpose or not, but the 4 signals are YMCA. So they're building this little chip, and they said, we have a really tough problem right now because this little chip goes in everything. It goes in handheld devices, it goes in aircraft, it goes in munitions, it goes in naval vessels. How do we possibly satisfy everyone and do it on time and on budget and on schedule and all this stuff They said, we can't win. I said, actually, you guys can't lose. With that diverse of a user set, I said, you can simplify something, and say you only satisfy 75% of your customers. You can go to those small number of people who didn't like it and say, you know, I understand you wanted this feature, this function, this thing, but I'm sorry, we couldn't do that because, hey, we have all these other people we also have to engage with and satisfy with, and there are other considerations, and you know, you're not the only one who's has to be taken into consideration here. It's so important, and I didn't mention this before, let me say this again, let me say this now. This is something we need to do with our customers, not to our customers. With our colleagues, not to our colleagues. A big part of this is to use this as a visual vocabulary to have these conversations. And like I mentioned, with my teams, I like to take them and say, okay, what happens if we go here? How do we get in this direction? So with that GPS system, I said, look, trying to satisfy everybody will end up satisfying nobody. And it turns out, to get it back to that principle I mentioned before, a simple system tends to outperform its specs. It tends to do more than it was designed to do. Just when you look at kind of the history of the most important, most impactful, most innovative new technologies and systems, tend to be the ones that are simple, that were designed for one or two primary functions. And then the users figure out how to make it do all kinds of things that the engineers never envisioned. The users sort of figured out once it's in their hands. So how do we get it into their hands faster? By having a constrained requirement set, by having a simpler architecture, by simplifying things. So as we had this conversation, one of the chief engineers, I think it was the chief engineer, says, well, what if we take out the Y signal for this chip? What if we just don't address the Y signal? Because you got YMCA. And then I don't remember what they actually decided for that particular chip, but that was exactly the right question. Maybe the answer was, if we take out the Y signal, that would break the system for a large number of our customers. Can't do it. But maybe nobody would miss it. And so it's that type of conversation that this is designed to help foster. It's kind of a long answer to your question, but did that kind of get in the neighborhood, or do you want to have a go back? Or? Okay, very good. So to sort of reiterate a point that we made briefly earlier, there's two kinds of simplicity. There's weak simplicity and strong simplicity. The guy who I mentioned at the opening who said, in my company, we're not interested in simplicity, I fear simplicity. This is what he feared. The inadequate, the sterile, the underwhelming simplicity that's just not good enough. I ordered soup, I got hot water. Too simple. Okay? Strong simplicity is that elegant, rich, engaging simplicity. I got miso soup. Very simple, very engaging, very rich. They're two different things. And the secret, the other little twist here, is that in order to go from weak simplicity to strong simplicity, we need to go through this, what I call the area of inelegant preparation. This is where we're breaking the eggs to make the omelets. You can't shoot straight across. We need to allow complexity to rise, to get higher, and then begin to take it down. Because this is where the learning takes place. This is where the experimentation takes place. And if you do it right, and we end up here, it might look like you did no work. And boy, that's frustrating. Because the solutions that you find in the lower right corner tend to look obvious, intuitive. Well, that's very simple. You must have just whipped that right out. It's very hard to get to here because you have to go through all of this. But all of this hard work, all of these learning, all these experiments end up being hidden from the end user, end up being hidden from your boss even sometimes. And I've had a couple gut check moments when I go in to brief my boss, my commander on something, and I've got something that I think is here. Boy, I hope he understands what I had to go through to get to that very simple, elegant, streamlined, high value level of simplicity. One thing to watch out for is what we call premature optimization. When we start simplifying too soon, and the final goodness that you achieve here is much less than the goodness you would have achieved if you'd gone through that whole process of experimenting, trying things, letting it get messy. All right, the most important line in the entire presentation, the most important line in the whole book, simplicity is not the point. The goal here is not simply to reduce complexity. Goodness is the point. To move to the right. Goodness, value. And if goodness is the point, making things gooder, making things better, increasing the value, addressing the measures of merit, satisfying those customers' interests, the only way we can do that is if we have that conversation with, not to. Something we do with our customers, our colleagues, and our partners, not to them, but to have this conversation with the people who get to say what goodness really is. We all get to have a part of that conversation, and we can be the one who initiate the conversation. One of the ways to initiate the conversation is just to draw this little complexity versus goodness graph and say, hey, I think we need to go from here to there. I think we're about here and we need to move down and to the right. If we need to move down and to the right, what are the design tools? What are the techniques we should adopt? Or no, I think we're still early enough. I think we need to move up and to the right. There are things we need to add to this system, this design, this thing that we're making in order to make it better, in order to satisfy the interests of our customers. Great, so let's use those additive tools and techniques as a way to make it better. And again, other times, once we've done that, we need to move down and to the right. And the nice thing is, when you hit that lower right corner, you'll know. You'll absolutely know. People will tell you, wow, that's really simple, it's really elegant, I love it. All right, so that's kind of the end of my prepared talks, but I have one bonus chart for you. And that is, I just recently published the comic guide to the simplicity cycle over at uxmagazine.com. You can go and just download the PDF. I think they've got it all laid out as an individual, a whole web page. So it's kind of the comic version where this character's name is Janet. I made her out of PowerPoint, and a PowerPoint chart just out of shapes and things, and she sort of walks through the experience of a junior designer trying to understand how do I improve the quality, the value, the goodness of my design. So yeah, you can go to, there's the whole URL is up there, or if you just Google Simplicity Cycle Comic and my name, it should come right up. So that's kind of the extent of my prepared comics, you guys, or comments. Questions, comments from any of you now?
How do you help encourage people to engage that conversation? People are used to thinking about it as familiar as being what's good, or what solves an immediate problem they have in front of them is good, as opposed to seeing the global space. So how do you encourage that when you are looking at it from those perspectives?
Sure. We can give them my book. How do you have that conversation? You know, I think a lot of times what it really comes down to is you just sort of have it, and you can start the conversation by saying, all right, can we talk about what's our goal here? What's our objective? You don't need to use the word goodness necessarily. You don't need to draw this out. I usually do. And I found it to be helpful. Hey, you know, if we were to chart this out, where do we think we're heading? What is goodness? What is the value? What is the objective? What are our most important requirements? Sometimes it's as simple as, what's the most important requirement? What are the 3 most important requirements on this particular effort? You know, and if you can kind of use that to start the conversation, again, part of the challenge in having these talks is that the word's simple and complicated. There's just so much baggage around these words. Because for some people, simple means good. Other people fear simplicity. If someone says, hey, you're very simple-minded, that's not a compliment, you know? And so simple, just it's got, so if we just say, hey, I think we're here and we need to go there. Wow, look what happened. I said here and there and I moved my arm. It's a visual vocabulary. It takes some of the baggage of some of these words off the table and gives us a new way to talk. So I'm a big fan of kinetic discussions and visual discussions as a way to, you know, make it a little bit less threatening. You know, because again, some people just are all about simplicity and some people just hate it. This way we get to talk about it without, you know, getting some of those barriers removed. Yes?
I don't know if it's a question or just a comment.
I'll take either.
But sometimes the customer, a lot of times our customers seem to fight things taken away because it means their job goes away. Right? So if you look at kind of the history of like infrastructure and stuff we deal with, you know, the admin function, you know, has been kind of abstracted away.
Sure.
With a lot of things. So it's hard to get, you know, when you deal with these kind of, you know, kind of model shifts, it's hard to get a measure of goodness. You know, and
It is.
abstraction abstraction in general is a good thing, but it also can create, as far as systems design, lesser outcomes when you do that. So I don't know
Sure.
if there's necessarily, but any, thoughts on, because, typically in the history goes, the way back and the roots go to the mainframe user that we dealt with, and those guys were knob turners. They loved,
Right.
the engineering and the complexity of systems because there were more knobs on the aircraft to,
Right.
to turn, and they had skills, and they were the only ones. But that the model shifted tremendously, and we're kind of in this transition of getting more towards automation and machine learning. Where it's hard to say who's to measure. How do you measure good?
Right.
How do you have that discussion with
Right.
take away?
Right, especially when the thing being taken away is someone's livelihood, someone's specialty, someone's, and I think Tom Peters has been predicting this exact thing, this white-collar revolution of, where it used to take 100 people to unload a ship. When you compartmentalize things and put them in containers, all of a sudden one guy could unload that ship. One person could do the work of 100. I think he said like 95 of these blue-collar longshoreman jobs went away. He said the same thing is going to happen with automation and white-collar jobs, and you see it happening with law, with taxes preparation, any number of situations. And there's no easy answer to that. I think Jerry Harvey addresses that certainly better than I could. His book, he wrote The Abilene Paradox, but my favorite of Jerry Harvey's books is called How Come Every Time I Get Stabbed in the Back, My Fingerprints Are on the Knife? And I emailed with him a while back, and I said, how in the world did your editor give you such a long title for your book? And he said, actually, the title was his editor's recommendation. He had wanted to call it When We Buy a Pig, which is, anyway, I'll tell you the backstory behind the When We Buy a Pig thing, too. But in his book, he talks about something called the Anaclitic Depression Blues. Anaclitic depression is a syndrome you often find in infants who are in orphanages, infants who are removed from parents and aren't held. It leads to failure to thrive and can even be fatal. Grown-ups can experience this anaclitic depression blues when our support structures are removed, when we feel like we're being left behind, when change is happening around us, these jobs are going away, automation's happening, and we feel like I no longer have a place here, and that support structure goes away. So he talks about how do you sort of address that, how do you recognize it, how do you mitigate it. Jerry Harvey, how come every time I get stabbed in the back, my fingerprints are on the knife? I hate to sort of point to somebody else's book, but it's really, really well done. Very thoughtful, very heartfelt, and very practical. But again, very important. And so I think part of that conversation and getting back to the whole do it with people, not to people, is say, okay, things are going to change. Nothing's going to stop that. How do we make this change in a way that is least impactful, least hurtful to the people who are most affected by it? And I think that can be part of this goodness discussion as well. That's got to be a component of our definition of goodness.
Great.
Cool. Well, I think
Just before we break up, so I hope you use spell check when you write the book, because gooder is not a word. But I know it's like a few other ones in there, but
I use the word kabillion, and my copy editor changed it to kajillion, which apparently is a word, but kabillion is not.
yeah.
So,
Well, so speaking of the book, so we have a special treat. We had 5 copies of the book to actually give away for the 5 people that tweeted us from the EMC Dojo account. So Steve, congratulations. You are the first recipient of the book. And Sydney, do we have any other winners? So Twitter handle is EMC Dojo. If you go on there now, we have 3 more books available.
Right.
You can retweet us. Not you. You can't get one. Notice the similarity between your Chuck. Okay. Is Chuck here? Hey. Thanks, Chuck. And Sydney, you let us know.
right, tweet fast, yeah. Yeah, so thanks again for doing the 5 giveaways, so appreciate that.
Yeah, you're welcome.
And I will be sitting over here autographing and signing if anybody wants.
I think next time we have to have you come and tell some stories of your service.
That'd be fun.
I've been fortunate to I could sit there for hours and just listen to the great stories. So awesome. and similarities, because your boss at the in the Navy could shoot you, and
Right,
sometimes
right.
I feel like mine is going to as well.
Yep, yep. So I hope this was helpful for you. I hope it was interesting. I hope you found something
Bizarre.
useful. And again, I don't know what decisions you get to make or what problems you get to solve, but I suspect a lot of the decisions that we make and the problems we solve do relate to questions of simplicity and complexity and goodness, and having that conversation with the people around us. 'Cause we oftentimes don't get to make these as solo people. It's part of a conversation, it's part of a community. And hopefully this kind of stuff will help make that part of your life simpler and gooder.
I'm good.
So, thanks.
Thank you so